right, so in this video, we are going to do example 1. It gives us some motivation for why we would want to estimate areas under curves. Not just because it's fun, but what kind of applications, how could it be potentially useful to us? All right, so example 1. You are driving on the freeway. You get up to speed at noon, and you look down at your speedometer every hour. Assuming that there is no traffic, and you don't speed erratically, estimate the distance you traveled from 12 to 4 p.m. That is what we are being asked to do. All right, so we can approach this either with a table. They give us some of the information with the table of values, but we can approach it by looking at that as well as graphically. Okay, so hours after 12. So 0 hours after 12 p.m., in other words, right at noon, you look down at your speedometer and you see that you are going 55 miles per hour. Let's go ahead and graph that. If this is my time axis, T hours, and it's really after that 12 noon. 0 hours after noon, you look down right at noon and you see that you're going 55 miles an hour. Okay? So that little ordered pair is right there on the graph. Then at 1 o'clock, 1 hour after noon, you look down and you see that you are going 68 miles an hour now. So at 1, you're at 68, which looks like about right there. You're at that little ordered pair. At 2 hours after noon, you were going 70 miles an hour. So 2, 70. At 2 o'clock, you look down at your speedometer and you see you're going 70 miles an hour. Then 3 hours after noon, so at 3 o'clock, you look down and you're going 65. So I'm going to put on the point 3, 65 here. And then at 4 hours after noon, you look down and you're going 62. So maybe right there. Those are all those ordered pairs. Now, we have to make some assumptions here. One thing that we can do, because this is just an estimation, is if I look down and I'm going 55 miles an hour and I travel for the full hour, assuming that I'm going 55 miles an hour for that whole time, the area under this curve right here is a 1 hour times, what are we graphing here? But the velocity or speed. Velocity does have a direction to it. It is a vector, but I think I'm going to just talk about speed is comfortable to us. Miles per hour. If I travel for 1 hour at 55 miles an hour, the distance traveled is also this area under the velocity curve, right? 1 hour times 55 miles per hour gives me the 55 miles that I've traveled, is that area. Between 1 and 2, I have some options. What if we assume right at 1 o'clock you are going 68 miles an hour, right? So if this is at 68, if we just assume, okay, you're going 68 miles an hour at that constant rate for a full hour, you've, again, got your 1 hour now times the height here. This is at 68 miles per hour. 1 hour times 68 miles per hour gives us that 68 miles. It sounds so weird to say that that area is representing a distance traveled. Numerically, they are the same. The area of this rectangle is 68, and that is our estimation for how many miles you have traveled between 1 o'clock and 2 o'clock. You then glance down at 2 o'clock and you see that you're going 70 miles an hour. Well, if we make the assumption that I am doing 70 miles an hour for that full next hour, I have traveled a total of 1 hour times 70 miles per hour. I've traveled a total of 70 miles. Right? All of the little changes in your domain, change in time if you want, they're all 1 hour. Okay. And I look down at 3 and I see that I was going 65 miles an hour. So if I make the assumption that I'm going 65 miles an hour for that full hour, that's obviously an assumption, because when I look down at 4, you're going less. You're going 62 miles an hour. But this is all the information we have, so we're going to make this estimation. The 1 hour times 65 miles an hour gives me the 65 miles that we have traveled. Okay? And I just graphed these ordered pairs, 0, 55, 168, again, right here, because we could have made different assumptions, right? At the beginning of this story, you were going 55 miles an hour, and then all of a sudden at 1 o'clock, you look down and you're going 68. This is an underestimation of the distance that you've traveled, because you weren't going 55 miles an hour for the full hour. You had to speed up. So you had to travel more distance, right? So an alternative, instead of using these left endpoints, if I look at the time interval, right, between at 0 is noon, I picked the time noon to get that, to use the function value of 55 for my height. And then for the next rectangle, I picked the left endpoint here of time being 1, and I got this function value t of my time at 1. How fast was I going? What was my velocity? It was up at 68. I'm using the 68 number, right? But what if I used the right endpoints? What if I assumed between noon and 1, what if I assumed I was going the 68 miles an hour the whole time? Now that's, again, we're only able to estimate here. This would be an overestimation, because I know that I was only going 55 miles an hour at noon, but it's still a perfectly valid estimation. So if I say I'm going to make the assumption between noon and 1 that my speed was a constant, my velocity was a constant 68 miles an hour. 68 miles an hour times 1 hour gives me the 68 miles. And then between 1 and 2, I'm going to use not the speed that I was going, the velocity that I was going at 2, not 1. I'm going to say, 70 miles an hour. Let's assume I was doing 70 miles an hour for that full hour. If I make that assumption, going 70 miles an hour for a full hour, I would travel 70 miles. Again, the distance under this velocity curve is representing the distance that I have traveled. Sorry, I think I might have misspoke. Someone's walking by my trailer. The area under this velocity curve represents that distance that I have traveled. Right? Between 2 and 3, I'm going to use the velocity, I'm going to use the speed that I was going at 3 o'clock. I'm going to use 65 miles an hour and just say, you know what, I'm going to assume I was going 65 miles an hour for that full hour. 65 miles an hour times 1 hour gives me the 65 miles. All right, and then lastly, between 3 and 4, I'm going to use the speed that I was going at 4 o'clock, the 62 miles an hour, and I'm going to just assume I was going 62 miles an hour for that full hour. 62 miles an hour times 1 hour gives me my 62 miles. So now, to estimate, we've got two different estimations going on here. To estimate the distance that we have traveled from noon to 4, one estimation would be our 55 miles an hour plus 68 miles an hour plus 70, oh, sorry, I'm saying miles an hour, plus 70 miles plus 65 miles. That's one estimation. And the other estimation would be 68 miles plus 70 plus 65 plus 62 miles. All right? So let's write that up. All right? So, one estimation that we have, adding up the 55 miles plus the 68 miles plus the 70 miles plus the 65 miles is 258 miles, the distance that we've traveled. The other one, adding these guys up, gives us 265 miles, right? In both estimations, how did we estimate the distance traveled? We were calculating area under our velocity curve. And we don't know the exact velocity function. You do not drive 55 miles an hour for a full hour and then all of a sudden, right at 1 o'clock, boom, now you're all of a sudden going 68 miles an hour, right? That is not how you're physically able to drive. You're probably slowing down and speeding up a little bit and eventually, or at least speeding up to get up to that 68 miles an hour, right? But we made this estimation by calculating the area. So crazy. Estimating distance by calculating an area. We calculated the area under the velocity function. Or just curve. I can fit curve in there. I'm going to write curve. Right? And that feels super, super strange. But yes, miles per hour times hours will give you miles. Right? Anytime you have an area or have a multiplication formula, you have an area model for understanding that product. How could we improve our estimation? This was pretty crude, right? I'm just checking my speed every hour. But what if instead I checked it every half an hour? You know, and at 12:30, I found that I was going 60 miles an hour. Well, I could have broken that up into some more rectangles. If we had more rectangles here, in other words, you had more information about the velocity you were going at each moment in time, we could have a better estimation. Right? Check our velocity or speed if you want more frequently. Right? Calculate the area of more rectangles. So what we're going to want, this is a calculus class, we're going to actually want to not just have 4 rectangles or 40 rectangles or 400 rectangles. We're going to want to have infinitely many rectangles. We're going to want to have some sort of limit here to get this exact distance traveled. All right, so this concludes our video of example 1 that is setting the stage for why we would want to find an area under a curve and how we might go about making that estimation.